probability. Suppose if you toss a coin, okay, so that's the first thing that we start with, isn't it? If you toss a coin, you are not certain about anything when you toss a coin. Either you can get head or you can get tail. Then we deal with the probability, isn't it? Now, when you toss a coin, what is the probability of occurrence of head? Speak out. When you toss a coin, you say that's equal to half. Am I right? How did you say that it is half? Now look at here. We say, so number of ways we get head. Okay. Number of events which is favorable to head divided by total number of possible events. Okay. This is the basic definition of probability. Probability of occurrence of A. Okay. Probability of occurrence of A, that's equal to number of outcomes favorable to A divided by total number of possible outcomes in any event. Okay, in any event, number of outcomes favorable to A divided by total number of possible outcomes. Wait a second, there is one more thing that need to be stated here, okay, which makes this definition complete. Okay, you are writing probability of head, that's equal to okay, when you are tossing one coin. Okay, you are tossing one coin. What is the probability of getting head? So number of outcome which is favorable to head. There is only one outcome which is favorable to head. Either head can happen or so tail can happen. Am I right? So again, total number of possible outcome 2, isn't it? Head and tail, isn't it? That's how you do. So, but there is one thing that you need to state here. Okay. So similarly, you can say probability of tail is equal to half. Am I right? Speak out. One thing that you need to take it here. Suppose when I toss a coin, okay? Suppose when I toss a coin. Have you seen Sholay movie? Have you seen Sholay movie? It's not of our generation, our parents' generation, isn't it? Anyone? Have you seen Sholay movie?
Yes, sir.
Yeah. How many times?
Yes, sir.
How many times?
Yes, sir. 3 times.
Those guys, I mean, our parents, they used to watch that movie many times actually, even in theater at that time. Yeah. So he had a coin with both head, isn't it? Both head or both tail, isn't it? Yeah. So that's a different story. Again, now look at here. What I do is, I'm going to put a wax on the coin, or I'll blow some air from one side, so that when I toss that one, I'll make probability of being head more than probability of being tail. I'll do something, isn't it? I'll make something. So I'm going to work out what you call some dynamics of that one. Okay. So that again when I toss that one, so I'll make probability of being head is more than that of tail. I'll make something. Then how do you write this? That how do you make this as so definition? Something is missing in this one. Am I right? So this definition is true only when these events are equally priori. None of these events are favored. When you toss the coin, either head or tail, they are not favored. Am I right? So now look at here. When probability of being head is equal to probability of being tail, then only you can write that's equal to half and half. Isn't it? So now look at it. Probability of being head plus probability of being tail, that should be equal to 1. Am I right? That's what you know. Okay. Now, if you write probability of being head is equal to probability of being tail, then you can substitute here and you can write this one as 1/2. What is this definition? This definition is they are equally probable. Am I right? They have equal priority. of occurrence, isn't it? None of them are favored, isn't it? Either head or tail. In the natural experiment, not the experiment that I am designing. In the experiment that I am designing, I will make one of them favored than other. In ideal case, they will be equally favored. Is that okay? I mean, none of them are favored. Is that okay? Suppose I design one what you call thought experiment, where one of them are, so one of these two are favored than others. Then they are unequal, am I right? Then you can't write half and half. So that's why whenever you write this definition, okay, you should remember all of these possible outcome, whatever I said, those should be equally likely to occur. Okay, whenever I said probability of being head is equal to half, that means again that definition, okay, that contain that probability of being head and probability of being tail, those are equally priori. They have equal priorities. None of them are favored. Is that okay? Can you write this one? So again, this definition is true when all of these outcomes are equally likely to occur. Equally likely to occur. Or equally priori. Is that okay? We call that one as some theorem of equal priori probability. That is needed for statistical physics also. Otherwise, you can't define that probability at all. Is that okay? Yeah. Now the next question is, look at here. The next question is, so you said probability of getting head is equal to half, am I right? What is the exact meaning of this one? This one we already discussed this one, okay? Suppose if you toss a coin once, okay, you got head, okay? If you toss a coin second time, then also you got head. Then how do you explain this half probability? Speak out. I think I did explain this one already, isn't it? Suppose if you toss a coin twice, okay, both of times, suppose if you got head, then I will say just like what you call Amitabh Bachchan in that movie, you have a coin with both head, probability of getting head is 100%, I say like that. But you had an ordinary coin, okay? Then speak up. Increasing number of trials, isn't it? If to show this probability, you should have infinitely many trials. Am I right? We have seen that one, even in case of quantum mechanics, isn't it? If you toss a coin twice, okay, ordinary coin, okay, just forget about that one, surely part, okay. So if you have an ordinary coin, when you toss that one twice, suppose if you get both time head, how do you convince that one that probability of being head is half? By tossing twice or thrice, you can't show that one. You have to toss 10 times. Then you may get 4 head, 5 tail. Sorry, 4 head, 6 tail. Is that okay? Then how do you show that one? How do you show that it is 50-50? Then you have to toss that one 100 times. Then you may get 49 head, 51 tail. Then also it may be unequal, isn't it? Are you getting my point? Then you have to toss that one 1000 times. Okay, when you make that number of trial, okay, infinity, okay, near to infinity or very large, okay, that ratio of number of head to the total number of trial you made, that will be equal to 100. Sorry, that will be equal to half. Is that okay? Now look at here. This is the actual, what you call, definition of probability. Again, experimentally, how do you prove that one, isn't it? So let me take, if n trials, if in n trials, okay, if in n trials, event A can happen, and event A happens in m times, okay? Event A happens m times, okay? If in n trial, an event A happens n times, is that okay? Now, probability of A, let's say put limit n tends to infinity, m divided by n. This is the actual definition of probability. I mean, practical definition, isn't it? That means you have to make number of trial infinity, then, so total number of what you call event, that is favor to this one, divided by, so total number of trials, okay? So that ratio is our probability actually. By just making some what you call less, very small number of trials, you can't talk about probability. You can't show what you call any probability what you call values. Is that okay? Speak out. Suppose let me take, so this is a basic definition. Now suppose let me take, look at here. You have tossed the coin 10 times, okay? You got 4 head. Is that okay? So each and every time you are doing the trial, you are getting 1 less head, okay? Is that okay? 1 less head. It is unequal. Let me take like that, okay? So again, you are tossing that 100 times, but you are getting 49 head. Unequal again, okay? You are tossing 1000 times, you are getting 499 head. Is that okay? So then what is this value? What is this value? What is this value? Even though I have taken 1 head, again number of head that is less than 1 less than number of tail. Okay, when you take more number of trials, this value is tending to 0.5, 0.4, 0.49, 0.499, 0.4999. Are you getting my point? I have taken one hypothetical trials where number of head is 1 less than number of tail. Okay, and I'll do 10 trial, I'll do 100 trial, I'll do 1000 trial. Is that okay? And my value is what you call getting closer to 0.5, half. Isn't it? That means if you increase this one to infinity, this will be purely 0.5. This will tend to 0.5. Are you getting my point? So that's why by just tossing that one once or twice, you can't show that probability value. Okay, you have to take infinitely many trials. Okay. One more way of finding the probability is creating the sample space. Okay, I hope you might have done that one in class 12th. Suppose you are tossing 2 coins. Okay. Okay, what is the probability of first coin? Okay, let me name them. This is coin 1, coin 2. Okay, you have 2 coins. This is coin 1, this is coin 2. Okay, you are tossing those 2 coins. Okay, what is the probability that first coin head, second coin tail, isn't it? That's the question. So then what would you do? You can go for sample space actually. We call that one a sample space. What are the possibility that can happen, isn't it? So first one can be head, second one can be head. Both of the coin can be head. First one can be head, second one can be tail. First one can be tail, second one can be head, isn't it? So both can be tail, am I right? These are the 4 possibility. We call it a sample space. Okay, first coin, second coin. Is it okay? So we call this in a sample space. Head, tail, head, tail, isn't it? Okay. Now again, when you collect all possible outcomes, that is a sample space actually. And again, as according to our equal prior probability, all of these are equally probable. How many are there? 1, 2, 3, 4. Am I right? Each of them are equally probable means 1/4 probability for each. Speak out. Are you getting my point? According to our equal prior probability, each of them should be 1/4 probability, so that total probability is 1, because you should get any of these, isn't it? Speak out. Now probability of getting first coin head, second coin tail, that's equal to first coin head, second coin tail, that's equal to 1/4. Probability of getting both head, that's equal to 1/4, isn't it? So usually in this kind of problem, simplistic problem, okay, you can go for sample space and you can find your probability. Okay, can you practice that one? It is there in NCERT textbook. Okay, going to sample space and finding the probability. That in some problem you have to go for sample space. Some problem without going to sample space you can deal with that one. Is that okay? Yeah. A coin tossed 3 times. Can you quickly do? A coin tossed 3 times. A coin tossed 3 times. Okay. A uniform sample space. You can generate sample space. Okay. Look at here. What is the probability of at least 2 tails in succession? What is the probability that we get at least 2 tails in succession? I mean one after other. Now this at least word is very frequent in any probability question. Is that okay? At least word. Okay. What do you mean by at least? What is the probability that we get at least 2 tails in succession? That means probability of getting 2 tails or probability of getting 3 tails. At least word contains that one. Least 2 tail. Maximum anything can happen. Is that okay? Yeah, speak out. Now, so what is the probability that we get at least 2 tails in succession? Now I'll go for sample space. Okay. Coin is tossed 3 times. Okay. Head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail. Speak out. Tail, tail, head, tail, tail, tail. How many? 1, 2, 3, 4, 5, 6, 7, 8. I remember from this one 0, 0, 0, 0, 0, 1, 0, 1, 0 from digital electronics. 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. From that one, head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, head, tail, head, tail, 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 head, tail, tail, tail. Okay. How many? 8. Am I right? Each of these are equally priori. Each of these have probability 1 by 8. Am I right? 1 by 8, 1 by 8, like that, isn't it? Now look at here. Now, what is the probability that we get at least 2 tails in succession? Okay. Now look at here. Here you got 2 tails in succession, one after other. Here you get 2 tails in succession. And he put at least 2 tails. You can get 3 tails also in succession. Speak out. How many how many are favored? 1, 2, 3. Isn't it? Or you can say this is 1 by 8, this is 1 by 8, 1 by 8 probability, 1 by 8, 1 by 8, 1 by 8, 1 by 8, 1 by 8. Just add these 3 probability. That's 3 by 8.
Sir?
Yes.
Sir, PhD also at least 2 tails.
Speak out.
PhD.
THT, no. Again, in succession means one after other. THT, this is not one after other, am I right? This is after you got head, then later you got tail, am I right? Coin is tossed 3 times. Look at it. Succession means one after other. You got 3 of them which are favored for that one. Total possibility is 8, okay? You can think of that basic probability definition. Number of event which is favorable divided by total number of possibility. Or you can think each of these are equally probable. That's why each of them have 1 by 8 probability. That's why you can add these 3, these 3 probability. That's also another idea. 1 by 8 plus 1 by 8 plus 1 by 8. But remember, at least word, you should be able to understand at least word. At least contain, at least 2 tails in succession means probability of getting 2 tails in succession or probability of plus probability of getting 3 tail in succession. At least word, am I right? At least 2 means either 2 or 3, isn't it? Maximum is 3 here, isn't it? Speak out. Try to understand the word at least in any probability problem. That's very frequent. Is that okay? Speak out. It's a good question. Now let me go to some probability theorems, okay? So this is quite tricky part, okay? And later we can use binomial distribution and other idea to solve many problems, okay? Usually they are asking question on binomial distribution, Poisson distribution, like that, okay? But these basic probability theorems are also quite important. I think you can refer NCERT textbook also, okay? Look at here. So there are 5 black ball and 10 white ball in a box, okay? I have a box, okay? 5 black ball, 10 white ball. Inside a box, okay, you have 5 black ball and 10 white ball. Is that okay? Now look at here. We draw 1 ball at random, okay? We draw 1 ball at random. One question is there, look at here. What is the probability? Again, you have drawn 2 balls, okay? You have drawn 2 balls. Again, this font is very small in Mariel Bose. We draw 1 ball at random. Then without replacing first ball, we draw another. Okay, look at here. We draw, okay, 2 balls. Okay. We draw 2 balls. That means we draw first ball randomly. Then without replacing that one, you have drawn second ball. Okay, there are 2 events here. Speak out. There are 2 events. Are you listening?
We draw 2 balls together or one?
No, again, one after other. One after other. First ball is drawn. After that, you are drawing second ball without replacing the first ball. Is that okay? We draw 2 balls without replacing. Okay, we draw 2 balls without replacing. Okay, we have drawn first ball. After that one, without replacing, we have drawn second ball. Okay, there is 2 events. Okay, drawing first ball and drawing second ball. Event A, event B. Can I say like this? You have 2 events here. Don't forget. Okay.
Sir, without replacing?
Again, later they ask question about replacing. You draw 1 ball and you replace and you reshuffle and you draw other ball. Okay? Is that okay? Just like for cards, you are going to draw 1 card and you are seeing that one and you are replacing, you reshuffle that one and you draw another. Okay? Without replacing means one after other. You have drawn, totally you have drawn 2 balls. Okay? After the end of this event, you have 2 balls. Okay? Yes. Now the question is, find the probability that first ball is white and second ball is black. Find the probability that first ball is white, second ball is black. Find the probability that first ball is white and second ball is Speak out. How do you find this probability? You go for sample space. How many elements will be there in the sample space? Many elements. Am I right? You can't go for sample space and you can't find this one. Okay. Now what we do here is look at here. What is the probability of occurrence of this one? What is the probability that first ball is white? Look at here. Probability that first ball is white. That's equal to how many total balls are there? 15. How many favored? Number of events which are favorable to white ball. How many favored? 10. Isn't it? You have two events, drawing first ball, drawing second ball, okay? Probability that first ball is white, second ball is black, isn't it? Then probability that first ball is white, okay? That is 10 by 15. Speak out. Yeah, why are you thinking? Yeah. So then probability that second ball is black. Look at here. After this one, okay, let me call this as event A. Okay, this is event A. So you are talking about event B after event A has happened. You have already done first ball, okay? Then you are talking about probability that second ball is black. First ball you have already drawn. You found the probability, okay? After this event, what is the probability that second ball is black? Now, how many balls left there? What is the favored? 5. And this total probability is multiplication of those two. It is 10 by 15 into 5 by 14. Is that okay? Now, in this kind of, again, you have two events, okay? Event A, event B, can I say like this? Event A, event B. And you have probability of event A and probability of event B, okay? But event B depends on event A, actually. Is that okay? In this situation, event B depends on event A. Wait a second, I think event B depends on event A, isn't it? The total probability we need to write like this. Probability of event A into probability of event B, but event B depends on event A. Don't write this on 5 by 15. Is that okay? Event B is happening after event A. After event A, something else is happening in the whole system, am I right? This event B is not on fresh system after event A, isn't it? After event A, again, number of balls is decreased there, isn't it? So that's why, while dealing with probability that second ball is black, that write it 5 by 14, the total probability is a product actually. Is that okay? Now we shall take one theorem here. These are the what you call probability theorem.
So sir, this is excluding in the second event.
In
the second event, I mean, it is excluding by the first event or what?
What do you mean by excluding?
Because one excluding from the 15 balls.
Yeah, again, I have subtracted one ball. Yeah, excluding that ball only. I have written 14 there, isn't it? Now look at here. We shall take a theorem, then try to apply that one. Again, with one or two problem, you will not get a hold on this one, okay? One thing is solving the problem logically, other thing is applying the theorems, okay? So two different ways are there. Now look at here, probability of event A, probability of occurrence of event A and event B. Look at here, and is there in between. Event A and event B, one after other. Is that okay? So that's because we are going to call it as PAB. Okay, we are going to call it as PAB. That's equal to PA into PB. What we write? We write A here. Event A and event B, one after other. Okay, probability of occurrence of event A and event B, one after other. First event is A, second event is B. Okay, in this order it is happening. Okay, now that's equal to probability of occurrence of event A into probability of occurrence of event B, knowing that A has happened, because event A may affect probability of occurrence of may affect the probability of B, just like here, isn't it? This event is decreasing number of balls here, isn't it? That's why exactly the same idea. Look at here, you better write PA is probability that A will happen. Probability that A will happen. Okay. PB of A, that probability occurrence of, wait a second, PB of A is probability that B will happen. Probability that B will happen. Probability that B will happen if A happened. If A already happened. Is that okay?
So what is the meaning of the word N?
Which?
And A and event B. Event A and
Both event A and event B. You have two events. A and B. Yeah, speak out.
So that shows
Probability of occurrence of event A and event B. One after other. Probability of getting first one tail, second one head. If you are tossing that one 2 times. Is that okay? Speak out. Apply that one to simplest particular thing. Then I think you can experience something. Okay. 5 black balls, 10 white balls. Okay. So again, what is the probability that first ball is white, second ball is black? Okay. So now again you have drawn 2 balls. That's why again drawing first ball, again drawing second ball, or again in the second event. Okay. While you are drawing second ball, so that is affected by the first event, drawing first ball. Okay. So that's why again you have to write that one like this. If suppose these two are what you call exclusive, okay, suppose if these two are independent, you don't have to quote this one actually. If those two are independent, if one event is not affecting other event, you don't have to quote this one. Okay. If A and B are independent, okay, if event A and event B are independent, okay, are independent. What do you mean by independent? One is not affecting the probability of other. Is that okay? So if event A and event B are what you call independent, then probability of event A and B, okay, probability of occurrence of event A and event B, that's equal to probability of A into probability of B. We don't have to quote that one if they are independent. Okay. That's a special case of this one. We shall take an example, okay? That okay? Speak out. Can you keep this one in mind? Now look at here. Example, 3 tosses of a coin. Of a coin. Now you have 3 events, okay? Tossing that one first time, first event, tossing that one second time, second event, tossing that one third time, third event, isn't it? All 3 are independent. Why? While tossing second time, it doesn't matter whether you got head or tail in the first time, isn't it? All are independent. Not like that 8, that 10 and 5 balls. Is that okay? There you are drawing. When you draw that one in the second event, number of balls are decreased actually in the box, isn't it? This is different, okay? So that's why 3 tosses of a coin, okay? Now what is the probability of getting, all 3 heads? Now look at here. What do you mean by this one? Try to write that one in a statement. what is the probability of getting first one head, and what is the probability of getting second, again, what is the probability of getting first one head and second one head and third one head, am I right? And came in between. What is the probability of all three head? That means this is equal to probability of first one head and, am I right? Whenever and comes, you have to make the product. Speak out. And second one head and third one head. Is that okay? You have and, am I right? So that's equal to probability that first one head into probability that first one head, second one head, third one head. Look at here. This is equal to probability that first, again, probability of getting head in the first, what you call, so toss, isn't it? That's equal to probability that first head, second head, isn't it? When you toss coin first time, okay, what is the probability of being head? That is 1/2. But second time, that's also 1/2. Third time, that's also 1/2, because those are independent events, am I right? Each of the tosses are fresh actually, isn't it? Now look at here. How this happened? What is the probability of all three head? Let me write head, okay? Now go for sample space. Head, tail, head, tail, 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 head, tail, tail, head, tail. Am I right? All of these are 1/8 probability. That's why this should be also 1/8. This is what you got here. Again, I went for sample space to find its probability. Only one is favored out of total 8 possible outcome. That's why 1/8 is the probability here. Now here I have used that theorem. Is that okay? Both will give the same answer. Are you getting my point? Try to understand each and every example completely. So then that means you know how to apply the theorems. Is that okay? Then you don't have to go for this sample space, am I right? You can write half into half into half here. Speak out in the question. Yeah. Someone mic is on. Any questions? Speak out.
Sir, we can remember that from digital electronics that you said today.
This sample space. Yeah, that's what I remember. Okay. 0 0 0 0 0 1 0 1 0 0 1 1 like that. Okay, whatever. Okay. Most of the case you don't have to write the sample space. Sometimes you may need to. Okay. But we always try to avoid drawing the sample space. In this exam, yeah, you can draw the sample space. But in other exam, it may be very difficult. Am I right? I mean, in other example, isn't it? It may be too lengthy to write this whole sample space. That's why we take this theorem. Look at here, you don't have to write sample space. You know what is the probability of occurrence of each? And this one, and this one, and this one, and in between, am I right? You just take the product. Yeah, speak up.
Sir, in the last problem, there was probability of at least 2 tails in succession. Can I do this in this process? Is it possible?
At least 2, you have to divide it into 2 parts and then you have to add. Okay? Wait a second. I need next theorem actually.
Sir, exam proposing problem.
Wait. I need next theorem to use that one. Okay? That at least problem. Okay? Not only this one. Okay? At least contain either 2 or 3, isn't it? Or came. Either or, isn't it? I need next theorem. Wait a second. It needs practice. Okay? So still, I mean, even after this much practice, still I get confused actually. Okay? With it's all skill. Okay? Some people will have very good skill in solving this one. I have only experience, no skill here. Okay? You have to develop some skill here. But after some experience, you will develop skill. Yeah. Now it's you are totally confused, isn't it? Whether experience or skill, that does matter. Both actually, okay? 3 tosses of a coin, okay? All 3 are head. We don't have to go for sample space. So what is the probability that first one head and second one tail and third one tail? Half into half into half. Because probability of getting tail is also that like that, isn't it? Try to answer other question, okay? Yeah. Speak up.
Sir, if we don't specify the position of tail like first head, second head, third tail, we say that what is the probability of getting 2 heads and 2 tails?
Wait a second.
Sir, then it will be not 1 by 8, na?
No, then it will not be 1 by 8. Then also it will be 1 by 8 actually. Check it
Sir,
out.
if we don't specify the position, if it
Wait.
first
2
tail,
by 8 into 2 by 8. First head and second tail. No. First head, second head, third tail. That's what you are saying?
Yes, sir. I am saying if we not specify the position, we are just saying that what is the probability of getting 2 heads and 1 tail only. So that then, sir, it will be 1 by 8 or something else.
No. Again, it is exactly correct. It will be something. Head, tail, tail, head. Am I right? It can happen in 3 different ways. It will be 3 by 8. That's correct.
Yes.
Now I went for sample space here. Okay.
Okay.
Wait a second. We shall see whether it can be done with any theorem here. Okay.
Sir.
Now look at here. Sometimes sample space is necessary, okay? Sometimes it is not. Again, you need a practice to say when it is sample space, when it is when it is not required, okay? Now look at here. So next one is, look at here, probability of happening of either A or B or both. Probability of happening of either A or B or both. Probability of happening of either A or B or both. That's equal to, we are going to write P of A plus B. Okay, that's equal to P of A plus P of B, wait a second, minus P of AB. Where this is probability that both occurs. Probability that both occur together. Now, why we need to subtract? We need either A or B or both, isn't it? Why we need to subtract this one? Look at here, while writing probability of A, you have counted this probability also. While getting probability of B, you have counted this probability also. That's why this probability is counted twice here when you add these two.
Can you replace like B A intersection B?
No, don't write that intersection. I'm not comfortable with that one. If you have done, you just rewrite this whole thing in terms of intersection or union, okay? I'm not comfortable with that one. I'm comfortable with A plus B, A dot B. A into B, okay?
That symbol actually nice.
Yeah, okay, that may be comfortable. Just try to rewrite this whole thing with that statement. It is there in Gravel actually, okay? Check that out, okay? Now look at here. Probability of, in the probability of occurrence of A, you are concentrating only on A. In this probability, again, probability of occurrence of both A and B came actually. In this probability of both A and B came actually. That's why that probability is counted twice. That's why you have to subtract 1. Probability that both occur together. Is that okay? This is probability of happening of either A or B or both.
Sir, can you show that by an example?
Wait. We'll solve example. Otherwise, none of this can be remembered. Okay. A plus B, that's equal to probability of A plus probability of B if A and B are mutually exclusive. What do you mean by mutually exclusive? One more word came here. Am I right? I didn't use this one. Okay. Mutually exclusive means if A happens, B will not happen. If B happens, A will never happen. Then there will be no probability of them happening of them together, isn't it? Is that okay? A and B are mutually exclusive means if A happens, B will not happen. If B happens, A will not happen. Then they are mutually exclusive. Then this probability is 0, isn't it? That's why we don't have to, talk about this one. Now let me solve one question here. 2 students are working separately on the same problem. Okay. This is a problem. Okay. 2 students are working separately on the same. Are you getting my point? Have you noted this down? Try to apply this one. 2 students are working separately on a problem. Okay. If first student have a probability half of solving it, okay. First student have a probability half of solving that one, okay. So can I write P1 that's equal to half? First student, okay. Second student have a probability 3/4 of solving it. 3/4 of solving it, okay. Probability of solving the problem. Is that okay? Now the question is, what is the probability that at least one of them solves it? Probability that at least one of them solves it. They are working separately, okay? They are not seeing each other. If one solves, other will not copy him. Is that okay? They are working on this separately. They are independent, okay? They are independent. Is that okay? Every information will be there in the question, okay? At least one of them solves it. That means probability that either first student solve it or second student solve it or both of them solve it. This at least word contains this one. What is this one? Either first student or second student or both student. Isn't it? Either first student or second student or both student, isn't it? Probability that at least one means, I hope you grabbed this at least word. At least one means either one or both, isn't it? Is that okay? Not less than one. Both of them should not fail. Okay? At least one means at least one of them should have solved the problem, isn't it? Either one or both of them, isn't it? Now this is equal to, look at here. So this is equal to either first one or second one or both. That's the earlier theorem, whatever I have defined, isn't it? So that's equal to probability that first student solve the problem plus probability that second student solve the problem minus probability that both of them solve the problem. Alright, you have to subtract with that one. Speak out. So again, probability 1 into 2, okay? Since they are independent, that's equal to probability of 1 into probability of 2. This is the first theorem. What is the probability that both of them solve the problem? What is the probability that first student and second student solve the problem? That's a multiplication of these two, first theorem. A and B, first student and second student. That's just multiplication. That's equal to 3 by 8. Am I right? So this is nothing but this probability. So this is equal to, look at here. So 1 by 2 plus 3 by 4 minus 3 by 8. And the values, check this out. 8 common. 2 4 the 4 2 the 8 1 I think 7. Check that out. Try to do this problem again, okay? Let me mention that one, okay, from Mariel Bose. Problem number, okay? Speak out. So this is probability of both, means probability of first student and second student. Are you getting my point? So there is a this much probability that both of them solve that one together. Okay, that probability exists here also actually. That's why you have to subtract. If you keep only these two, you have counted this one twice actually. That's why you need to subtract once to get the probability, either first one or second one or both. Then you will get the correct probability. Is that okay? Speak out. You need some practice, okay? Unless it's quite difficult. Wait a second. Let me take some gravel problems so that we shall have some practice. Yeah, speak up.
Sir, in this type of questions, sir, I'm more comfortable according to you have mentioned to solve this problem. We can also take like probability of student is solving the problem into probability of B not solving problem.
Okay, yeah. That's very good. That's very good. Look at here. Now, this at least, you can write like this. Probability at least one of them solves the problem. That's equal to 1, look at here. Let me write like this. Probability that at least one of them solves the problem. Okay? Plus probability that none of them solve the problem. That should be equal to 1. Can you agree with this one? Probability that at least one solves the problem. What does this contain? This contains probability that only one student solve the problem, or probability both students solve the problem. Am I right? So plus probability that none of them solve the problem. This contains, this is a total way. Either this happens or this happens actually. When you add these two probability, you should get 1. Is that okay? In a typical case, either this happens or this happens. Either at least one student solves the problem or no student solves the problem. Is that it? So then addition of these two probabilities should be equal to 1. Then this probability can be written as, look at here. So can I go here? This probability can be written as 1 minus probability that none of them solve the problem. What do you mean by this one? This means A will not solve the problem, B will also not solve the problem, and it contains and. Is that okay? This contains first student will not solve the problem and second student will not solve the problem, which is just a product. Look at here. So 1 minus, okay, if this is probability of solving the problem, what is the probability of not solving the problem? 1 minus 1 by 2, that's equal to 1 by 2. If this is probability of solving the problem for student 2, what is the probability of not solving the problem? That is 1 by 4. That's why it will be 1 minus product of these two. What is this one? 1 by 8, 7 by 8. This is probability of solving the problem. Probability of not solving the problem, how do I write that one? P bar 1 by 2. Okay. Probability that second student will not solve the problem. That's equal to P bar of 2. That's equal to 1 by 4. That's 1 minus this one, isn't it? Now, 1 minus probability that none of them solve the problem. What do you mean by probability that none of them solve the problem? That means probability that first student will not solve the problem and probability that second student will not solve the problem, which is just a product. Is that okay? Can you write 1 minus of 1 by 2 into 1 by 4, that's equal to again 7 by 8. This other way of solving this at least question. Let me take many more questions, okay? Then you will understand.
Sir,
Yeah, speak out.
if event is more than 2, then how to solve this technical?
If it is more than 2,
Yes, sir.
then usually you have to think about AB, AC like that. You have to subtract by AB, AC like that, okay? I have written minus PAB, am I right? You have to write minus PAB, minus PAC, PA plus PB plus PC, okay? Minus PAB, minus PAC, these things you need to do actually. Is that okay? You have to subtract with much more terms actually. Check that out if there is any example like that, okay? And one more last one, I don't know where it is applied. Just have a note on this one. Wait a second, we shall solve some more problem together, okay? Probability of event B, probability of event B, okay? Probability of event B, assuming that event A occurs. Event A occurs. Okay? So this one we are going to find like this. PAB is equal to, I have written earlier statement, PA into PB, that event A occurred. Am I right? From this one, we just solve this one for this one. PAB divided by PA. We shall see, okay? If any example, we shall see this one. They call it as Bayes theorem, Bayes, Bayes theorem. Okay? A box contains 5 red ball, 10 black ball, okay? 5 red balls, 10 black ball. Is that okay? A box contains 5 red ball and 10 black ball, okay? 8 of them are placed in another box, okay? 8 of these are placed in another box. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay? 15 balls were there. 8 of them were placed in other box, okay, randomly. What is the chance that later contain 2 red and 6 black balls? What is the probability that it contain 2 red and 6 black balls? How do you start? How many balls are there? 15 balls, isn't it? What is the total number of possible ways of choosing 15 balls here? Total number of possible ways of choosing 8 balls out of these 15 balls. Speak out.
15C8.
15C8, am I right? This is the total possibility. So now this is the denominator of your probability, 15C8. This is the total number of possible outcomes. Is that these many different ways you can combine 8 ball, am I right? Out of 15 ball. This means again here there is nothing like you have to place that one in order. It's not permutation, okay? Yeah. Here it's just a collecting 8 balls, combining 8 balls, isn't it? Out of 15 ball, grabbing 8 balls. Speak out. There is nothing like ordering them and all, okay? Yeah. So this way it's a combination. This is a total number of possible ways of combining 8 ball or choosing 8 ball out of 15 ball. Is that okay? That's the denominator. That's the total number of element in the sample space. Now look at here. What is the favored one? 2 red and 6 black. 2 red and 6 black. Look at here. I said and in between. Multiplication. Isn't it? What is the probability? What is the total number of again? How to say?
Sir, 5C2.
Yeah.
5C2 into 10C6.
What is the probability of getting 2 red?
Out of 15 balls.
Now, it's a kind of principle of counting. Numerator is a kind of principle of counting.
We have 15 balls.
Hmm.
Out of them, we have to collect 2 red. 15C2.
Again, out of 15, what is the possible way of getting 2 red ball and 6 black ball, isn't it? Speak out.
Out of 15 balls or out of 5 balls?
Speak out. Out of?
Sir, out of 15 balls, we have to choose 2 red balls.
No. Look at here. Now, numerator is a principle of counting. What is the number of possible way of getting 2 red ball? So here we are not taking the ratio of probability. Here we are taking the ratio of 2 numbers. Numerator is a number of ways of getting 2 red ball and 6 black ball. Am I right? So that's a number of ways, one after other, 2 event. Am I right? You are grabbing 2 again. You are grabbing total 8 ball. Okay, you have 2 event, isn't it? So now look at it. It's a principle of counting here. Yeah, speak out.
Sir, in the last case, when we did this kind of probability of first ball white and second ball black.
No. There we multiplied by probability. Okay. Again, we multiply. Again, here I'm applying different concept, not of any of those 2 theorem. I'm not applying any of those 2 theorem. I'm applying my original concept. Number of event which is favorable divided by total number. We shall do one by one. Okay.
In the last case.
Speak out.
We just did in the last case, so we can also do like that in that.
Yeah. You can go for that one, but I think this is also simple because you know what is the combination things, isn't it? Yeah. Anyway, so try to do the same thing using that theorem. Okay.
Logically, we can say that.
No, but there what happened is you have drawn 8 balls. Am I right? You have to think of each of probability. And then you have to multiply. I get my point. You have 8 balls here. Okay, there you have drawn only 2 balls. Am I right? In the earlier example, but here you have drawn 8 balls. That's why it is simple. Look at here. Now, what is the number of ways of getting 2 red and 6 black? What is the number of ways of getting 2 red? That's equal to 5C2. What is the number of ways of getting 6 black? That's equal to 10C6. And this is the required probability. Is that okay? That's equal to 5C2 into 10C6 divided by 15C8. Numerator is a principle of counting here. Okay, I'm not applying any theorem here. Is that okay?
Sir, sir, in this question, first we drawn out 8 balls from those 15 balls, na?
No. Here you just need. I'm not applying those theorem. Is that clear?
Sir, I'm confused that first we drawn out 8 balls from 15 balls and then we are applying 2 red ball from 5 red ball. Sir, is it necessary that if we drawn out 8 balls from those 15 balls, there will be 5 red and yes. Sir, is it
No.
necessary
Here I'm not dragging them again. Okay. Here, what is the probability that this collection contains 2 red and 6 black? Probability that this collection contains 2 red and 6 black. That's the question here. From this one again, I'm not grabbing this one. Okay. But the probability that this collection contains 2 red and 6 black, that's the question. Is it?
Okay, sir.
Yeah.
Okay.
Yeah. Now this is just a ratio. It's a just ratio of this one. Number of event which is favorable divided by total number of possible event. Is that okay? Now look at here. A bag contains 8 white balls and 6 red balls. A bag contains 8 white and 6 red balls. Okay? 8 white and 6 red. Eight white ball and 6 red ball. Okay. What is the probability of drawing 2 balls of the same color? Okay, you have drawn 2 balls. Okay, only 2 balls. Now you can apply the theorem. Is that okay? Now you can apply the theorem. What is the probability that both of them of the same color? Okay. Now this contains 2 probability. Probability that both of them is red. Probability that both of them is. What is the probability? You have drawn 2 balls. Okay. One after that. Okay. What is the probability that both of them? Probability of drawing the 2 balls of the same color.
Same color.
Same color. You have drawn 2 balls here. Okay. What is the probability that those 2 balls of the same color? Now this contains 2, 1. Probability that both of them red plus probability that both of them white. So what is the total number here? 6 plus 8, 14. What is this probability? Speak out. Probability that both of them red. So take the ratio here. What is the total number of possible way of drawing 2 ball out of 14? 14C2, am I right? Okay. Among them, what is the number of favored one? Both of them red. How do you write that one? Speak out. 6 C 1 or 2. This is the number of possible way of drawing 2 red ball out of 6 red ball, isn't it? So this one is again 14C2. What is this one? Both of probability that both of them white. What is that one? 8C2. You need to add them.
Addition white or either or.
This one and this one again. Yeah, again either this one or this one, or that's why you have to add that one. That's correct. Is that okay? Either both of them can be red or both of them can be white, isn't it? Or either or, isn't it? That's why you need to add them. He said probability of both of them of the same color. He didn't say which color, isn't it? That's why you have to add both probability. Is that okay? Now you know cards. You know cards.
Yes, sir.
If anyone don't know about card, you have to get to know about that one, at least for solving these problems. Okay, they don't mention how cards will work and all. Is that okay? You need to learn that one. No other choice. Okay. So I hope you know that card contains this one, diamond, heart. These are red one, isn't it? Other two, I think spade, and what is this one? Am I right? Or ulta? Ulta? I too don't know. I too don't remember. No, this one. Yeah. These two are black. These two are red. Isn't it? Am I right? Because they talk about sometimes black and red also. Okay? Yeah. What we call diamond, heart, this one, spade, club. Club. It is called as club actually. Okay? We call in something else in our regional language, isn't it? Yeah. So diamond, heart, spade, club. Is that okay? I hope so. Okay, I too don't exactly remember. You just look into it. Okay. So each of these contain Eka 1, 2, and so on to 10. J, K, Q. Am I right? Eka 1, 2 to 10. J, K, Q. Am I right? King, Queen. Okay, J, Q, K actually. It's in order, isn't it? While we play Q, K. Q, K.
Sir, one near IIT one रहता है.
Speak out.
Sir, IIT one रहता है.
Yes, speak out.
Sir, one नहीं रहता है. IIT one रहता है. Yes, sir. There is
One will not be. Okay.
no one.
Eka is 1. Am I right?
Yes, sir.
Okay. After Eka, it will start from 2. J, Q, K. Yeah. It's been long time. Isn't it? Now look at here. How many total cards are there? 1, 2, 3, 4 and so on up to 10, 11, 12, 13. 13 cards, okay? Each of them contain 13, total 4 times. Total number of cards will be 14, okay? They say well shuffled deck of cards. Deck of cards. Is that okay? Find the probability of drawing an ace or spade or both. Ace means Eka, okay? Ace means Eka or 1 actually. It is used somewhere in some other problem also. They say just ace. Okay, ace means 1 actually. Or here it is Eka. This is called as ace here, okay? What is the probability of drawing an ace or spade or both? Write down. Drawing. What is the probability of drawing an ace or spade or both? Because in spade you have ace, am I right? Spade is a type actually. Ace is a number. Are you getting my point? How we club the problem? Okay. So this equal to probability of getting ace plus probability of getting spade minus probability of getting ace spade. Now in this problem you will understand what happens if we are not subtracting. What is the probability of getting ace? How many aces are there in the 52 cards? Speak out. 4 aces are there, am I right? 1, 2, 3, 4 of different type. Okay. So how many spades are there? How many spades are there? 13. 13 spades are there, am I right? Out of 52. Now when you do this one, look at it here. If you take only this probability, okay, you have counted that one twice actually. Look at here. Something came twice.
Ace and spade.
Ace spade came twice actually. That's why you have to subtract from what is the probability of getting ace and spade. Ace and spade.
Ace with spade.
Okay. Ace with spade. Is that okay? That's equal to 1 by 52. Only one ace spade is there. Okay. Spade type ace.
Black color.
Okay. Black color. Not black color. These two are both are black color. This is spade. Black color means this two, both, this whole thing is black color actually.
Only the two.
This is spade. Is that okay? You have to find like this. This is the application of second theorem. Is that okay? So try to do that one. I think we better do one more problem. Okay? It's also gravel problem. Solve both gravel and Muriel both as well as some NCERT problem. I think that would be quite sufficient. Okay? Now look at here. Two cards are drawn in succession. Yeah. A problem number, let me mention in the homework. Okay, it is problem number 26.13. I mean, you have to just open up gravel in the chapter 26. Okay, probability and distribution. You better solve from the beginning. Okay, all problem, all example problem. Okay, that's better. If any difficulties are there, let me solve that one. Okay. This is for example number 26.13 in my book, okay? Gravel. Probability of drawing an ace or spade or both, okay? Now look at here. Example 26.14, okay? Two cards are drawn in succession from the pack of 52 cards. Find a chance that first is king, second one is queen, okay? Two cards are drawn. Okay, probability that first is king, second is queen. Wait a second, there are two types. First one is if card is replaced. Second one is if card is not replaced. You have drawn two cards, you got two choices. One is you can draw first card and you can replace and you can reshuffle and you can draw second card, okay? Or you can draw one after other. Total two cards at the end of second event, okay? So second one, if card is not replaced. First one king and second one queen, am I right? It's an and statement, am I right? So that's why if card is replaced, look at here, what is this one? This is equal to probability that first one is king, isn't it? So this is king, queen, that's equal to probability of king, probability of queen. Now these two are independent. Why? You replaced and you reshuffled, assume like that. Both are independent event. One doesn't depend on other. Is that okay? That's why this is equal to, how many kings are there? 4 kings are there, okay? 4 by 52 multiplied by how many queens are there? 4 by 52. Is that okay? But here, your card is not replaced. So that's why second card event depends on first event. That's why this one, PKQ, that's equal to P of K, okay? P of Q, that K has happened. Application of first theorem. Is that okay? That means you have drawn first card, okay? What is the probability that first card is king? What is the probability that second card is queen? Probability that first card is king is again 4 by 52. But you are not replacing that first card, whatever you have drawn. How many cards left? 51 cards left. What is the probability of getting Q? That is 4. Is that okay? So try to apply all theorem. I think that would be sufficient. Is that okay? Event A, event B. One case, both are independent event. I think I told both are exclusive. No, not exclusive. Exclusive is different. Independent is different. Both are independent here. I told both are independent. One event doesn't depend on other event. Okay? But here one event depends on other event. Is that okay? Second event depends on first event. Since here you are replacing card, okay? Both events are independent, okay? Yeah, try to work out some problem, then it would be good, okay? NCERT, Mariel-Bose as well as Grable, okay? I mean, if you work out all example problem, that would be sufficient, okay? From Grable. Chapter 26, Probability and Distribution. Not later part, okay? He worked out Bayes theorem and all, not later part, only this basic probability part, okay? Later part, let me discuss tomorrow. Problem set 26.2. You can try some outside problems so that you can check out whether you can solve or not, okay? From Mariel-Bose, you can start solving, you can start dealing with chapter number 15, Probability and Statistics, okay? 1, 2, 3, 4, 5, 6. First 10 pages, okay? That's sufficient.